Okay, so we've got this flowchart where we start our program, we read in A, print A, and then finish. And when we look for that flowchart, it looks like we're going to get the output of the letter A, but that's not actually what's happening. So what we need to do is really investigate what's going on inside the computer to see how this program will work. So what we'll do is talk about the computer memory and then look at the output we get on the screen, because print means put this on the screen. So we're not going to get the letter A out, so let's look at what happens inside the computer memory. Now, rather than thinking of the memory as a bit of hardware, we're just going to draw this as a table, and our memory here we will have to store things here in these green boxes. Now, memory comes in huge capacities, and here I've just got 4 boxes to put things in and 4 other boxes to label those things with a name. So we're going to think of memory as programmers, not as memory. We're going to call it a variable or variables. And when we do our read in A over here, what we're actually saying is we're going to read in whatever the user types in to their keyboard. So keyboard over here typed in, and in memory location A, in other words, in our variable A, we can type in our name or whatever else we want to type in. So if the user happens to type in Fred in capitals, then over here, when we do the print A bit, what's going to happen is it's going to print Fred in capitals. Now, that's all well and good, but if we take our program on a little bit further, so now we've got the same program, read in A, print A, but then we read in A again and print A again before we end. So let's carry on and do what we just did. We did the read in A, so the user's typed in Fred, so Fred gets stored in this memory location A, and then it gets printed to the screen. Now, when we do the next part of the program, read in A again, what that's asking the user to do is type in something else. So if the user, let's just delete this a second, if the user happens to now type in Joe, what happens is Joe, capital J, small o-e, is going to be stored in that memory location. Now, each memory location can only hold 1 bit of data at a time. So we can't keep Fred in there. We can have other memory locations to look after different names and things, but each variable can only hold 1 thing at a time. So now, when we move on from here, when we trace this down to print A, what this is saying is print whatever is in the memory location A, which is of course now Joe. So over here on our screen, it prints Joe. And then of course, after printing, we trace that down and we go to end. So our program finishes. Okay, so let's take you back to what we looked at before. When we said think of a number greater than 5, write the number down. Is the number even? If it is, divide it by 2. If it isn't, multiply it by 3 and add 1. And then it both comes back to here. Is the number 1? No. We'll go round that loop again. Write the number down and so on. So some of you will have sussed that from before, but what I've done is put that same program over here. And what we're going to look at is how this works in terms of our memory, in terms of computer memory and those variables that we store, whether it be letters, numbers or pictures in. Okay, so I've tried to use the right symbols and I've added some colors to help you see the difference in the boxes here. So the start and finish are the terminators. That means the start and beginning of the program. The parallelograms are in green, which means data, which is input or output. We've got the yellow diamonds, which is a decision or a question, which is why they always end up with a question mark, and each decision will have a yes and a no coming out of it. And then we have some processes in blue, which means the computer's just doing stuff internally. So this is the same program. Let's go through this. Start, enter a number larger than 5, and that says print. So what's happening is that's being printed, and because it's in speech marks, the words enter a number larger than 5 is being printed on the user's screen. And then we read in something called num. Now, num is this bit of memory. So if we take what we had before, so we've got a bit of memory, but my bit of memory is going to be called num. Now, we read in the number, and whatever number the user has put in is going to be the number that gets used. So I'm going to try and start with something reasonably easy. It doesn't take me too long to go through. So I'm going to start with the number 6, the next one that's bigger than 5. Okay, so in this area of memory that's called num, we put in the number 6. We go down to the next part of the program, tracing the arrow down. Is num even? Well, this is num. Is it even? Yes. Let's go down to num equals num divided by 2. Now what's happening here is a process that says, okay, let's update whatever num is with a new number. So we take whatever num is, 6, divide it by 2, and then we put the answer from that into num. So in other words, we're going to get rid of 6 now and replace it with half of 6, which is 3. Go down here. Is the number 1 or is num 1? No. So let's go back up and we get, it's like difficult tracing this, and we go down to is num even? Now 3 is not even, so we have to say no. Come out of here, go down to num equals 3 times by number plus 1, a bit like it was over here on this diagram, multiply by 3 and add 1. So remember, num is currently 3, so we do 3 multiplied by 3 is 9, plus 1 becomes 10. And that gets stored, the answer to that bit gets stored into num again. So let's get rid of that. Remember, 3 times 3 was 9, plus 1 becomes 10. So the number now stored in num is 10. Okay, so moving down, following the flow of the flowchart, is the number 1? Nope, it's 10, because that's what's stored up in our num. And so we carry on up. Is the number even? Yes, 10 is even. So what should I do? I follow the yes down and put number divided by 2 into num. So let's update what's in the memory. Now we're going to replace it with 5. Okay, we've got 5 and follow this down. Is the number 1? No. Go back round again. Is the number even? No. Multiply it by 3 and add 1. 5 now becomes 3 times 5 is 15 plus 1 is 16. So we got 16. Is the number 1? No. Go round. Is it even? Yes. Divide it by 2. It becomes 8. Is the number 1? No. Is it even? Yes. Divide it by 2 then. It becomes 4. Is the number 1? No. Is it even? Yes. Divide it by 2. It becomes 2. Is it number 1? No. Is it even? Yes. And finally, and let me just make a point here, that all of these things, even though I'm just scribbling them out for speed, all of these things do not exist anymore in there. It was 2 and it's now being replaced with the number 1. So when we get down to this question, is num 1? And what we mean by that is what is in this memory location 1? Yes, it is. Right, great. We can finish the program. And that's how memory's working within this program. We've got an area of memory which we're calling a variable. Our variable we've called num. We can call it anything we like. It could be a like it was before. It could be the word number, or it could be anything. So let's just have a look at that in terms of a slightly different program now. We're going to not read in a value or a number. So what we've got here is an area of memory that's called value. So this is my area of memory. We're going to call it value. And value is initially set as 10. And then it says print value when we follow the flow down. So if we think about our computer monitor, this is my very rough drawing of a computer monitor. Sorry about this, not very easy to draw. Keyboard and so on. So on my computer monitor it says print the number 10. So 10 gets printed. Then it says value equals value minus 1. So what happens here is we're taking value minus 1 and we're going to update it into value. So we do 10 minus 1 is 9. So what we're actually doing is rubbing out the 10 and replacing it with the value we've just calculated, which is 9. Is the value 0? No, it isn't. It's 9. So let's go round, back up, and now we print the value again. So we go back to our monitor and we print the number 9. So we keep going around. Is the value 0? Sorry, print value. Value equals value minus 1. So now we've got to subtract another 1 from here. So we change that to be 8. Is the value 0? No, go round, print the value, and so on. So you'll find, if you follow the flow of the program through, that this does a particular thing. Now, I'm going to leave that with you to see if you can work out exactly what it does. Once you've worked it out, put your hands up and let your teacher know.